Okay guys, here's the second 2 pages of the honors review packet. So for this top section up here, my orange highlighter is dying, but I'll see what I can do. We need to solve for x and y. Well, we have right triangles inside of right triangles, so that tells us we have to use boomerang or roller coaster. Well, for number 10, both of the things are on the outside, so we're going to use boomerang. I'm going to do x first. I need to go across the whole side with the 2 parts, capture the x, and go back just to the 1. So the whole first side was 10, the whole next side was x, the whole next side was x again. That's okay that we're repeating it, and then back over 1. If I cross multiply, I get x squared equals 10, and we can leave this just as x equals the square root of 10. Well, now I need to solve for y. I'm going to use my green highlighter. It's also going to be boomerang. I'm going to go across the whole side. I'm going to capture the y, and then go back just across the 9. So when I solve for y, I'm going to have the whole green, which was 10, whole green, which was y. We went back y, and then back just the 9. If I cross multiply, I get y squared equals 90, so y is the square root of 90. Now, for some of my classes, we've practiced simplifying radicals, and so for you guys, you need to simplify this to 3 root 10. However, if we haven't practiced that yet, you can just leave it as root 90, and you should know which classes you are. For 11, we have something on the inside for y, so I'm going to use boomerang to capture y. Oh, sorry, not boomerang, roller coaster. So I go over 2, up y, back down y, over 6. That's going to give me y squared equals 12. So y is the square root of 12. And for classes that have practiced simplifying, that'll simplify down to 2 root 3. For x, we have to use boomerang to capture the outside, so I'm going to go across the whole bottom, capture the x, and go back just across the 6. Whole side was 8. Then we went across the x, we went back across the x, and then just 6. That's going to give me x squared equals 48. So x is equal to the square root of 48, or if you can simplify, it's going to be 4 root 3. Okay, 12 says that a flagpole, so here's my an 80-foot shadow, a 12-foot street lamp, there's a little street lamp, casts a 30-foot shadow. How tall is the flagpole? Well, let's start with that. So we're going to have x over 80 equals 12 over 30. So I'm going to cross multiply and get 30 times x equals 80 times 20. Well, let's make this easier for ourselves. I see 10 on both sides, so I'm going to divide by 10. That's just going to give me 3x equals 8 times 12, which is 96. And if I divide both of those sides by 3, I'm going to get 32 feet for the height of my flagpole. Now it says, but why is it important that we measure the shadows at the same time? Well, that's because if the sun's coming in and making this thing, we need to make sure that the angle at which the sun is coming in is the same. These are both going to be perpendicular because they're straight up off the ground. This is going to represent that angle of the sunlight coming in. We're not going to have similar triangles if the sun isn't coming in at the same angle. And at different times of day, it'll be different. Okay, number 3 says, Mrs. Barnes is at her weekly workout class on Wednesday evening. She is standing in the back of the class 5 feet away from the wall. So here's 5 feet away from the wall. Here's me doing my little workout class. I'm noticing that the light is streaming through a window on the wall and creating an 11-foot shadow in front of me. So the sun, as it comes in, is making an 11-foot shadow in front of me. Think about it like this. A shadow is essentially wherever I'm blocking the light is there going to be a shadow, right? So as soon as the light can make it over my head, you're going to see light on the floor again. But that's why this is going to come in and make a triangle like this. If the top of the window is 8 feet off the floor, how tall is Mrs. Barnes? Okay, well, remember, we have 2 triangles here where x and 11 are going to go together, the height over the length of this first triangle. Well, the height of this new triangle is 8. The length of this bigger triangle is 16. Those have to go together. So what I notice when I'm doing this problem is 8 over 16 is the same as 1 over 2. That means 11 is going to be double whatever x is, so you can cross multiply if you want to, but you can also figure out that I apparently am 5.5 feet. I'm actually 5 foot 8 inches, but I will take 5.5 for now. Okay, let's do some proofs. Let's look at this one. Well, we want to figure out what the reason's going to, the very end is going to be first. Well, why are these similar? I know that these are going to be similar if they're similar at all by SAS, because I have two sets of sides for each triangle and I have a pair of vertical angles. So see, I have side, angle, included angle, side. The angle has to be directly in between, side, included angle, side. Well, let's make sure it's similar. I have 15 and 18 for the first triangle. I have 25 and 30 for my second triangle. Let's simplify. We want to figure out if these are in fact equal. This is divisible by 5 3 times, divisible by 5 5 times, divisible by 6 3 times, divisible by 6 5 times. Yes, they do have a common ratio. So all the teachers do these proofs a little differently. So if you're not in my class, this might look a little different, and that's okay. But here's how I would do this proof. I would say, okay, we need to show that we have a pair of angles that are congruent and two sets of sides that are proportional. I know now that BF over FG, I got those from here, the 15 to 25, BF, FG, is the same as the fraction ratio of CF over HF. And both of those simplified down to 3/2. Well, where did I get these numerical values from? They came from the picture, and the picture was given, so I'm going to call this given. A lot of other teachers split this in 2 steps, so make sure you're doing it the way that your teacher showed you how to do it. Step 2, I have my 2 sets of sides now, so here's the first set of sides that are proportional, second set of sides that are proportional. I can also say that angle CFB is congruent to angle GFH, oopsies, because they are vertical angles. That's the vertical angles theorem. Well, now I have a set of included angles between the 2 sides, 2 sets of sides that are proportional. So now I can say that my 2 triangles are similar by AA similarity. Okay, let's go on to number 15. When I look at this one, no sets of sides are marked, so my only possible option is angle, angle. Well, if you take a look, I already have a pair of angles that are congruent. I can get another pair because I have vertical angles. So here we go. Step 1. Angle S is congruent to angle F. Well, that was given to us. They told us that this was 86 and this was 86. Now I can do my vertical angles. I have to use 3 letters because angle E could be any of these angles. So if I want this one, GEF, GEFRES. That's the vertical angles theorem. Well, now I can say that my 2 triangles are similar. Remember, this symbol means similar because of angle, angle similarity. Okay, we got one more page. Here we go. We've got another proof. Now, this proof, I'm going to go through it the longer, complex way, but you could possibly get rid of 1 or 2 steps. So this is how I would do this proof. I would say, okay, let's start with the information that was given. We were told that RM is parallel to SN, that SN was perpendicular to NT, and that RM was perpendicular to MS. That's what we were given. Well, so far, sorry, give me a moment here. We've got that these are parallel. Okay. Because the lines are parallel, I know that this angle and this angle have to be the same, and this is why. There's my parallel line. There's my parallel line. This is my transversal. Those are corresponding angles. So I can say that that angle MRS is congruent to NST, angle NST, because of the corresponding angles postulate. And I have to know that my lines are parallel before I can use the corresponding angles postulate. Okay, well, I also know, according to this, that these are perpendicular. Now, by definition, if this is perpendicular to this, that means that the measure of angle M has to be 90 degrees, and the measure of angle N also has to be 90 degrees. That's what it literally means to be perpendicular. So definition of perpendicular. Well, since their measures are the same, that means that their angles are congruent. That's the definition of congruence. We'll take a look. Now I have a set of angles that are congruent. I have a second set of angles that are congruent. So now I can finally say that my 2 triangles are similar. Now, My guess is a lot of you wouldn't have thought to do this step 3. So if you had only had step 4 here, you would have put your reason here as definition of perpendicular or something like that. That would have been fine for now, but this is something we're going to practice how to be more explicit or more detailed in our proof. So that's how I would do that one. 17 is another explanation problem. I want you guys to spend time thinking about this by yourself, but I'll give you a hint that the important part, well actually no, I'll let you guys figure it out by yourself. So let's go down here. We need to do some solving problems. Now, I'm pretty sure I messed this up on the review packet key on Blackboard, but so a student showed these to me, so thank you if this was you. 1 foot is the same as 12 inches. We need to get all those units the same. So now I have that PQ is 12, teen, QR is 17. We need to solve for this whole thing, but first let's just start by solving for that. Now, these arrows here were supposed to be the things indicating that they're parallel. I know it's a little hard to tell, but I'm going to tell you that those are parallel, and we'll make sure it's clear on the test for you. But our idea is that if we have parallel lines, this over this is the same as this over this. You could also do this over this equals this over this, but Mr. Allen does it this way, and I think this is a great way to show what goes together. If you can do that arrow between the parallel lines, those go together. So I'm going to do that 12 over 14 is equal to 17 over x. Now, to make this easier for myself, I'm going to start by simplifying this. So I'm going to get 6x equals 7 times 17. Well, 7 times 10 is 70. 7 times 7 is 49. So 6x is going to equal 119. These are not going to be divisible by each other, so we can just leave our answer as 119 over 6, and they would be in inches. Sorry, I made a mistake. That's what x is. We want what SV is, so to get SV, we need to add 14 plus 119 over 6. The best way to do that is to realize that 14 is the same as, hold 1 second, 84 over 6. So for this problem, that's going to give me a grand total of, let's add this across, so 199, I think what's 203 over 6. So there's my final answer. I hope that's correct. I just did that off the top of my head pretty fast. Okay, B. Our next thing is if we have congruent angles, if we have an angle bisector that's getting cut in half, this over this is going to be the same as this over this. So I'm going to have 20 over unknown is equal to 24 over 12. Well, fortunately for us, this is nice to simplify. That's 2 over 1. So I'm going to get 20 equals 2x. So x is equal to 10. Okay, same thing here. Take a look. We've got our parallel lines. So this over this is the same as this over this. This is going to be 5, right? This thing here is going to be 22 minus 2x. I had 22. I've already used up 2x. So 2x over 6 equals 22 minus 2x over 5. I'm going to simplify this by dividing by 2. So when I cross multiply, I get x times 5 equals 3 times 22 minus 2x. So that's going to be 66 minus 6x. I'm going to add 6x to this side, and I'm going to get that x equals 6. Okay, let's keep going. Here we've got parallel lines again, so I can say this over this is this over this. That's going to be 2. So I can say 3 over 2x minus 2 equals 2 over 4. Well, look at that. 2 over 4 simplified down to 1/2. Okay, so when I cross multiply, I'm going to get 2x minus 2 equals 6. So 2x equals 8. So x equals 4. Okay, once again, I have parallel lines. I have 12 left over here, so I can say 14 over 8 is equal to 1 plus 2x over 12. Let's do a little simplifying. So now I have 4 times 1 plus 2x is equal to 7 times 12. It's going to give me a value of 84. So I get x equals 10. Okay, here's my last one. I have a bisected angle. So this over this is the same as this over this. Okay, when I cross multiply, I'm going to have to FOIL. So first is going to be x times x. That's going to give me x squared. O for outer, x times 2. Inner. Last. To solve this, I am going to have to get everything on one side. So this is another factoring problem. You're not going to have to do this for this test, but it is something we're going to expect of you soon. So now that I have everything on one side, remember these canceled out. I'm going to end up with x minus 4, x plus 1. Minus 4 times 1 is negative 4. If I add these together, I get negative 3. What makes this 0? I have a positive 4. What makes this 0? A negative 1. Negative 1 is no good, so my only answer is x equals 4. So there's the honors review packet. I hope it was helpful, and good luck studying.